Good afternoon, everyone. I'm Professor Gupta, and I'll be talking to you guys about the material and shaders in any 3D software. So let's start the thing. So first of all, the agenda of the session. First and foremost, what are we going to learn in the session? The first thing is introduction, like what exactly shaders are, and what are the types of shaders, what are the roles of shaders in the into the mesh, basically in the 3D software, and the practical demonstration in 3D software. So first thing first, what do you understand by the term texturing? When we talk about shaders, we are definitely talking about texturing, right? So what exactly the texturing is? I'm not sure how many of you have ever heard this word or have ever worked in the 3D softwares, but I think you guys have started learning with this modeling thing. So the next step is texturing. So what texturing is? When you learn to do a model, you get it done in a, what you say is a gray model with no color, no texture, nothing. Like you can never judge what is the material of the model, what is the mass of the model. So for getting all these things into your mind, you have to do the texturing thing. If I can say the texturing is nothing but a projection. So if I'm asking the question, what is texturing? The answer is nothing but projection. Will project a map over that model or the mesh, will project some qualities of that material on the mesh. So basically what the thing is, I can give a small example. If you have a ball or a sphere, like you have modeled a sphere, that sphere is of gray color. When you model it, how are you going to understand what exactly is the material of that sphere? Like if it is made of glass, if it is made of plastic, if it is made of rubber or cloth or anything xyz, that where texturing enters the scene. So what we do is we basically textured a gray model to something that create or develop the look and feel of that thing, of that mesh, of that model, right? I have portrayed an example. This is a gray model here on the very right side of mine, and the left one is the textured. So why texturing is required? It itself gives the answer. When you take a gray model, you never know what exactly the material is, what it is made up of. And when we talk about the 3D world, when we talk about the AVGC industry, when we talk about the media and entertainment industry, we have to make a resemblance of that world to our real world, to our realistic things, right? We take our references from real life, we take our ideas from the real life, we take our motivation and everything. Like we need to, we want to, and we have that demand to portray whatever is there in our mind to the 3D world with the reference, with the help of real world. So we need to have this texturing thing easy, handy, and we have to learn it, so that whenever we want to make anything into 3D, we have to make it with texture, not only the grayscale model. So this is why texturing is required, so that we can define the look and feel, the texture, basically if it is soft, if it is hard, if it is shiny, if it is matte. See, all these things we can explain, we can portray our things through the texturing thing. So there are two things in the texturing, basically not texturing, but when you develop the look and feel of a certain mesh, one is texturing and the another thing is shading. So when it comes to the term texturing and shading, I mostly get this question: what is basic difference between texturing and shading? Like both are doing the same thing. Now they are just defining the look of the object. See, it would be a gray color model. Uh, right now, it has a color. You can tell that there is a metal, there is copper, there is chrome, there is leather. So why? we have to like differentiate with such difficult terms. Texturing, like texturing is something different, shading is something different. See, the difference is when we talk about shading thing na, we only use some physical entities, some physical qualities of any material. What physical? That basically involves physics. It includes transparency. It includes shininess. What you can call is specular. You can call is ray trace. You can call it refraction. You can call it refraction. So these things are included into your shading thing. You never get a map, a 2D map, or any image from outside the software into the software to portray your texture or to portray your look and feel. All you have to do is you have to make a model. You have to play with the properties of that certain shader into the software. In 3ds Max we call it materials. In Autodesk Maya we call it shaders. When we move on to other open source softwares, that is your Blender and C4D and everything, so again there we call it shaders, right? So here, what I'm trying to tell you is basically shading didn't involve any type of external material or external map or external image to get into the software and portray your texture. What you can do is you assign or you apply the material and you just play with the given default or inbuilt attributes that is there inside your sorry, inside your software, right? That includes transparency, specularity, your ray tracing, your reflection, your refraction, etc. Next, the another term that we are using right now is texturing. I have this 3D model textured just to show you guys what till what extent our 3D world is going right now. So this is a textured model, believe it or not. Definitely render is done on a PBR engine. So yeah, the output is realistic, can be said ultra realistic. But this here we have done texturing. Why texturing? Because the thing you are watching here, these are the maps. So we have to get these maps out from outside your software. You can call, you can take it from Photoshop by making yourself, you can take it from internet. Even you can, what you can do is you can take a, or you can click a pic of that certain texture, you can import in and use it as your own texture, right? So texturing is a nothing but a 2D image mapped on your 3D object, right? The first thing is shading. The shading includes nothing of a 2D image, none of the maps, none of the things to be taken from outside the software. You have to use all the attributes inside what that is present in the software itself. But when you talk about the texturing thing, you have to get 2D image outside the software, take it into the software, do the mapping thing, and then apply that thing to the gray mesh, right? It may use for creation of pattern, roughness as an additional map, right? Why we are using the term additional? Because we are adding something from outside the software, from another source to the software. That software could be anything. It might be Maya, it might be Max, it might be Blender, anything. We are not talking about a specific software here. We are talking about the 3D software. So it could be XYZ, anything, right? Fine. So there are now two different types of texturing. First is bitmap. Bitmap is what basically the bitmap is what you call is you can call any image, any 2D map a bitmap. Bits and bytes are the entity, are the units in the computer. So map is made up of all those bits, basically pixels here. So what you can say is bitmap is any map, any image that you have to call from outside the your soft to the software, and you can use it as a texture. For example, the texture of these leaves. You can click a pic of the leaf and you can use it on your gray model. Texture of this bark, the trunk, right? You cannot make it through procedural. You cannot make it through physically based rendering or physical based material. You have to get these images outside the software. You have to get imported, and then you can use it into your mesh, your 3D scene. The second thing that is very famous nowadays, prior we used to have uh, it as a procedural texture, that is again something related to shading. Why related to shading? Because when we make a procedural texture, what we do is we basically make a texture that includes again roughness, specularity, refraction, retrace, everything, but we will be using only what are the attributes given inside the software or not taking anything from outside. But nowadays we have this physically based rendering, you can call it PBR. We have different materials of PBR. It has a whole new world that 3D softwares has included in themselves, right? Prior it used to be only Maya software. Nowadays we have another physical based software rendering plugin, basically you can call it plugin, inside your software. We can have Maya. Inside Maya we have Arnold. Another plugins we can include is V-Ray. We can have Marmoset for rendering. We can have again Mari. So these are some PBR render engines that has their own specific set of textures, yeah, shaders. They have their own specific set of attributes. They have their own specific set of lightings. They have their own specific set of basically rendering, right? What makes the thing common is, first of all, this is live rendering. Live matlab, this is when you work on the software, it continuously keep rendering. Okay. Second thing is, whenever you use PBR material, they directly interact with the light. Why light is introduced? Light is basically required to see each and everything, right? If we switch off the light, we are not able to see anything. Same thing happens in the 3D world as well. When we talk about the viewport of the 3D software, we need to have a light there, right? Without light, we are not able to see anything. It's not necessary that we have to put an external light or another light. There is a default light that is placed in the software in the viewport, and that light has to react with the material to generate a specific effect that is required or that is expected from that material, right? Okay. So there are two things. There are two different type of textures. First is bitmap. Another one is your PBR, that is physical based rendering. Fine. Let's move on. Okay. Next thing is render engines. I was talking about the rendering thing in the PBR. So we have two different type of render engines that is inside the Maya. We can render our models in XYZ in many ways, right? Like we can take it to another software, we can take it to another plugin, we can take it to another gaming engines where we get it rendered. But in the Maya, we have two different things. First is Maya software. Second is your PBR again, that is Arnold, right? Latest version, if we talk about the versions after to Maya 2016, they have indulged PBR renderer, that is Arnold, inside the Maya. What Arnold can do is it create really realistic, like actually ultra realistic type of rendering and texture, so that we can match the realism in the 3D world with of the outside world, right? Because what we can see nowadays na, ki prior the Tom and Jerry or Mickey Mouse was fine. Right now we have to have this realistic feeling in the 3D world, Because 3D is not only used in the cartoons, 3D can be used in the movies. There are many Bollywood movies that they have indulged 3D objects in them, but you have never noticed they use 3D for VFX things as well. They used to blast stations, platforms, and I'm definitely sure that was not the real platform right now. That was the 3D. That is CG. That is computer generated things. So to match that real world thing, we have to make everything in the 3D really actually ultra realistic, right? So there are two different type of render engines. The first one is Maya software, that is default render engine. The second one is your Arnold, right? So Arnold is now again your physical based rendering. It is your PBR. Fine. So after talking about detail about these things, like what is Arnold, what is Maya, what is need of texturing, why is texturing required, how we can use texturing in the mesh to make it look actually what it has to be meant for. Now we can jump to the basic shaders that we get in our 3D animation application. uh, that includes Max, Maya, Blender. So no specific application for the time. These softwares can found in any of the application, more or less, right? Because when we talk about 3ds Max, we don't have Lambert there. We have Blinn, and it work for everything. When we talk about Maya, we have all these set of basic your shaders inside it. So these are the shaders that you need to know if you want to learn basics of texturing. I'm not saying that we are going to get the masters today itself. It's a long and tedious process. 3D takes a lot of time, a lot of patience, and a lot of practice. But yeah, for the starting, these baby steps, they are perfect, right? So the basics materials, the basic shaders that we are having inside the Maya, it is Lambert, Anisotropic, Blinn, Fong, Fongi, and I'm introducing another PBR material, that is your AI standard surface. This is your Arnold material, right? So we'll be talking about all these things. We will be seeing all these things in your application as well. But let's understand what all of these are to be mean for. The first one I'm talking about is anisotropic, right? So anisotropic, what its quality is, it has specular, that is the linear. What linear means? I can show you. This is linear, right? Radial means round. Linear means something that has that is into a line, that is linear. So anisotropic as linear and irregular specular, right? Each and every material portray a different characteristic of itself. So the characteristic for anisotropic is it is linear specular. And what real life example you can match it to is hair, foil paper, your aluminum foil, CD, DVDs, even feathers. So if we have to make any of the thing into the 3D software, we have to use this material to get this result, right? So if I talk about hair, hair have a linear specularity. If we talk about aluminum foil, it again has linear but irregular specularity. DVDs, see, sorry, something that itself is a round in shape but has a linear specular. See, right? This thing is called specular. What specular is now? If you ask, specular is a point where light interact with your mesh. Right? Light is ray of light. It interacts with the mesh. It bounces back. And sometime if the mesh is transparent, it penetrates. That where reflection or refraction come into the light. These are the basic things that we have studied while we were studying physics in our 8 or 9 standard. So these are the things. So specular, light interact with your object or with your mesh. Again, if we come to the feather, we again have a specular. So this specular create a sense of light bouncing back, right? It creates something, angle where you can see the interaction of light with the mesh, with the color, with the material or texture of that specific object, right? So if we talk about anisotropic create linear and irregular specularity. Next, we blend, most used material, cause almost everything we have has some sort of shine in it, right? So blend has a soft specular and reflection at the same time. Anisotropic doesn't reflect things. Blend we used to get reflection again. If I can say that we can use blend to make a glass or mirror, I am sure it's not wrong, right? So metallic, your chrome. Metal includes not only your steel but also any XYZ metal you're thinking about right now. Copper, gold, silver, aluminium, anything. Of course, it has a specific amount of roughness, but whenever it comes to reflection and soft specular, we always switch to our blend. See, it has reflection, it has specular. Again, glass, it has reflection and it has specular. Car, or you can say car paint or metal, it has specular and again it has certain reflection, right? So these are the things that blend indulge in itself. You can have specularity and reflection at the same time, right? Soft specularity, for linear we have anisotropic, for soft we have blend. Next we have Lambert. Lambert contains no specularity, no reflection, no refraction, nothing. Lambert is something very matte, a material that need not to have shine. Hmm? Like chalk, like matte paint, the paint we use in our walls, right? The hardwood, dry walls, including your dry skin. If you talk about oily skin, it contains some sort of specular. But if the skin is dry, then again it is matte and unpolished, right? So something or anything with no specular, like a chalk, no specular, no bouncing back, no reflection. Walls, no reflection. Hardwood, no reflection, right? So these are the things that portray a perfect example of matte finish, that is your Lambert. So anisotropic, it has linear specularity. Blend, it has soft specularity and reflection. Lambert has no specularity and no reflection, right? Next is Fong. So it again contains reflection and some sort of specularity. So the only matte material in the 3D software is Lambert, right? So it contains some sort of specularity that is faded, like plastic. The specular line neither is very clear or the radius specular isn't very clear. But you can sense something like specular on that. You can sense that the light is reflecting back. You can sense that, yeah, it is shiny but very faded. So that's plastic, oily skin, telephones, and bathroom tiles. See, that's the specular. Your plastic wares, there is specular, but it's not very sharp, it's not very prominent, and neither linear at all, right? Or your telephone, the old one, that tring one, not the mobiles we have. It has got like very shiny finish nowadays. Prior, these telephones, they used to have this very faded specular, right? And the bathroom walls again. So these are the things that portray your real life examples, perfect references for your 3D or CG world. Lastly, mm, lastly, that is Bitmap, or that is in build for Maya render engine, is Fong. More faded specular, but very fast rendering. See, what happens is now, it is like the more you keep putting things, the more time you are giving your computer to render. It gonna take more time. Like if you use a matte material, it won't have to create specular inside because it's a machine, it's a programming, right? So it has not to create any specular in the system. It has not to create any reflection. It just have to calculate the amount of material, the color, and it has to give the render. So fine, no render timing increased. As you started putting the high-end materials, you started using your blend, you started using your fongy, anisotropic. It has specular, so it add-ons to the time. So why we need to think about the timing? Cause rendering again is a tedious job. It will be of no use no matter how beautifully you have textured if you are not able to get it render perfectly, right? So when we talk about Fongy, you can use this material somewhere where you need to have specular, but not that bright, not that sharp, or not that much required, right? The faded one, plastic or rubber, these things, so easy to render, fast rendering, and again it contribute into the specularity. Lastly, we have AI standard surface, that is your PBR shader. It has almost everything you need to make a perfect texture. Other than bitmap, you have to get it from outside. It contains transparency, a coat. A coat is a layer on the shader that create your color. Emission, metal. Emission, sometimes what happens, we have to make such things that has to emit light or colors from itself, uh, which we can call color bleeding, like moon. For short example, moon emit light in itself, right? So when you make such things now, PBR shader or PBR render engine is perfect for that. It gives you light that helps you emitting light. It gives you light that help, or even neon. If you have ever seen the neon signboards or the neon boards, it emit light from itself, right? So that thing, that is your emission, and we have to get it done through materials, not the lighting wala part, right? So metal, specular, reflection, refraction, sheen, diffuse, everything. Subsurface scattering, another a heavy word. We'll get to know about it. I'll give a brief example. Subsurface scattering is when a light intersect your material but not completely go out from the other side, unlike glass. So your skin is subsurface scattered. When you put a torch underneath your skin, you can see the red thing. So the light goes inside but didn't come out. That's why it's not transparent. Another thing is wax, that's candle. This again, it uses subsurface scattering. Grapes, that again use subsurface scattering. Light goes inside but never comes out, right? So these are the things that a PBR shader contains. Your skin. This is a realistic render of a 3D model, and here we have used AI standard surface. This is your subsurface scattering where light goes inside and never comes outside. Your specular, eyes may you can see the reflection, right? So you can see the roughness. Definitely the texture we are using is, we have to get it clicked from the real skin texture, but still there are, it has everything to get a perfect output, right? Another thing, this is again a realistic output of a PBR shaders. right? This is an output of PBR shader and PBR render engine, that is your Arnold. So with this, let's dive into the software and let's see what we have studied, how it gonna, use in the software, how we are going to use it. We can see some practical demonstration of it, right? So I'll be sharing my screen of this software. I hope these things are fine with you guys, right? You guys are getting what I'm saying.
Uh, Dear participant, you can use the chat box for SOP. And meanwhile, some question from the participant, ma'am. Like one
Okay.
question, even between the transition, we can go ahead. Like one question, dear ma'am, sometime we can easily distinguish the uses of 3D animations in Bollywood or Tollywood movies. But as far as Hollywood movies, we may rarely differentiate real scenes and animated scenes. Could you please enlighten about the difference between Bollywood, Tollywood versus Hollywood movies with some pertinent examples?
That's really a great question, sir. See, what happens is na कि there are certain set of what we can call is softwares. There are certain set of budget and there is certain set of knowledge that we'll be using in filmmaking, right? While talking about Bollywood movie, let's start with Hollywood. That the one thing that you guys are most affluenced of. Hollywood movies, they mostly go for the thing, they never compromises with the quality, right? They go for the thing that is more ultra realistic. They just keep introducing new things into the light, into the life, right? But Troy, you guys have seen, right? Uh, Perfect example, X-Men. You guys have seen X-Men series, right? It's like you can never differentiate that whatever things they are doing, is it real or VFX. If I can compare Bollywood and Hollywood right now, Bollywood is also in using some of the tricks and tips where you can never differentiate. If I can set an example, you guys have seen Om Shanti Om, I'm not sure if you watch Bollywood films. Om Shanti Om, there is a song Main Agar Kahun. You can see that the hero and heroine, they were dancing inside a snow globe. You guys really think that snow globe is real? That is perfectly 3D. It is made up of 3D model. It's a 3D CG generated model. So in Bollywood, again, you won't be able to sometime differentiate. Another thing is this PK movie, that Amir Khan wali. There is a blast scene of a railway station. That station was made completely in the CG. Another, I can say, the Dhoom 3 one. There they have created that bike. They have created some sort of jetty, and they have created the perfect example is that bank where the note is falling down. Those everything is created in CG, right? And Tollywood, they basically do things on purpose to make it look more appealing. They don't want to go to the realistic part. They just try to, because see, when we talk about the CG industry, when we talk about the entertainment field, we basically delivers what our target audience wants, right? So because we end of the day we are talking about the TRPs, end of the day we are talking about the sell our things. So the thing is ki, whatever the target audience of Bollywood, the Tollywood and the Hollywood demands, the same thing the industry is working upon, right? I can tell you this, let's don't take it otherwise, like in mostly we demand from the Bollywood is that dupatta and that yes, like proper romantic scene. So yeah, we create it in 3D again. We use CG, but not to make a X-Men, but to make that drape, that is, flying in the air with a proper romantic scene. I hope that answered your question.
One more query from a participant, ma'am. What about a KGF, ma'am? What you want to say about KGF movie?
It's a perfect blend, I would say.
Yeah. And like one more question from the participant, how this can be used in teaching engineering, ma'am, as academician, how we can get help from this?
That's a really good question, sir. While talking about engineering, see, I can tell you, for engineers, what you guys do is you make things, right? You make, you discover, not exactly discover, but you make things. So when you talk about 3D, and when you make that thing, whatever in your mind, into the 3D software, you are saving a lot amount of money, a lot amount of time, while whatever you will be using for making that thing into the factory or into your works, your workshop, right? You can make it into the 3D, you can check it from all the aspects, you can make whatever correction is required, and then when you implement that 3D model to the realistic thing, then when you implement it in your workshop, when you make it out of metal or whatever it is gonna consume less money, less amount of time, less hard work. So you can use this in your engineering field for product designing. The word we use in the 3D field is product designing. You can design any 3D thing, anything that you have made in your this sketches, and you can make into the 3D part, 3D model, and then you can make it. If you are satisfied with all the corrections and everything, then you can make it in your workshop.
Thank you, ma'am. Thanks for your input, ma'am. So I think now we can switch to the application for a practical demonstration. And like related to engineering, how effective into the animation, we having a last day session. So the total concept, maybe in the future, you may thinking whatever I had to read, I think you should be get learn the animation for your future only. This can be also happen after completion of this entire FDP. But meanwhile, lastly, we will get discussed. Thanks, ma'am, for your input. So we can go to the application. Thank you.
Thank you, sir. Okay, so I'm sharing my software now. Is it visible?
Yes, ma'am, it's a visible, ma'am.
Great. So you guys must be familiar with this viewport. This is your Maya. uh, I'll be, first of all, I'll be showing all those materials, all those shaders that I have talked about. What exactly the specular means, what exactly the linear specularity means, what exactly the matte thing means. So let's have a look. I'll create something. And let's have a sphere. Right. So I just made copies of the sphere so that we can use a different material on the different sphere, and we can, compare and judge the things at the same time. Right. So for applying material, what we can do is right click on your mouse, assign new material, and you get this dialog box. And here you get all the Maya materials, favorite ones: Blinn, Lambert, Fong, Fongy, and here is your Anisotropic. Arnold में you get this AI standard surface, right? So let's start from Maya material, and the first material I'll be using is the Lambert. I've clicked it and we have applied Lambert in the scene, right? Nothing changed. The only thing is we get a new tab here, which is known as Lambert 2. Why Lambert 2? Why not Lambert 1? Because whenever we get anything created into the software, first of all, we have default light. I can show you into the settings and Maya software, this common here. Options, we have default light, right? So as I have told you, we have default light set into the software. If right now I try to get a render out of it, I can see the things cause the light is on. But if I switch it off and try to render again, I am not able to see anything because there is no light in the scene. So as we have default light, we also have a default material, that is Lambert 1. Whenever you draw anything into the viewport, there is a material that is known as Lambert 1. And when we assign another Lambert, then again it's a Lambert 2. Or if I rename this as Lambert demo, right? So if I again assign a material in another Lambert, it will be Lambert 3 and not Lambert 2, right? So it works like this only. When you draw something, by default, it comes with a Lambert material named at Lambert 1. You never start texturing on that material, because whenever you assign a material to or a shader to a mesh, it has the tendency, like it controls or it basically memorize all the settings that you have done. So if you use this Lambert 1 as a primary your shading or your texturing material or shader, whenever you create another mesh, the same texture was pre-applied on that thing. So never use Lambert 1 for your shading thing. What we can do is we can just simply put another material. In this case, we are using Lambert. I can change the color, and there you can see no specular, no reflection, refraction, nothing. You can compare as I get another material. After Lambert, I can go for Blinn. See, this is what we are talking about when we are talking about your specular. That's the specular and it is radial, right? So I can name it Blinn underscore demo. I can I can color it. So this is your matte, and again this is your Blinn with some specularity on it, right? And again we have, if I open the Lambert attributes, I can only get this common material attribute and nothing related to specular. But when I open the Blinwala attribute options, this is your attribute editor, right? This one, you get all the parameters of your assigned thing. I mean, either it will be a material like shader, either it will be a light or camera. You can find every attribute right here, even of mesh. Every mesh has its own attribute, so you can get that here. Fine. So if I talk about this attribute, when we go to the Blinn wala attribute editor, you get the another session, that is specular setting. I can increase the specularity, I can decrease it. This is the radius. We call it eccentricity, right? This is the specular roll off. Specular roll off is the intensity. Then we have specular color. I can use different color specular as well. We sometimes use it to cheat about the light. Like lighting takes a lot of rendering time. So what we try to do is we try to get certain things via through the materials only. So I can use different color of specular to portray that there is a different color light that is interacting with the mesh and creating that very color ka your this specular. See, right? So there are some common things and then there is specular thing, right? Then we have reflectivity and reflected color that we'll be talking about later. Another, next we can use, we are done with blend, we can see anisotropic, see, radial and linear. So now you can understand that anisotropic creates linear specular. Now this linear specular can be adjusted to any angle. X and Y angles, and basically not angle but yeah spreads X and Y. X, Y, Z are the three coordinates of your 3D software, and again X sorry, X, Y is your coordinate in your physical world as well, that is length and width. Sorry, X that we sorry Z that we have is depth, so that is only for 3D world. For real life there is X and Y, so these are the length and width of your specular that you can adjust through your attribute editor manually. We have roughness. This roughness is of your specular, not your material, and not and certainly not of your mesh. Definitely, this is all about your specular shading. It contains some sort of roughness. Then we have Ferrand index, then we have specular color, same things. So we don't have to like think much about it. Yeah, but the thing we can worry about is angle, spread X, spread Y, and roughness. Right? I can again change it to yellow, the same color that we'll be using, so that you can easily differentiate or basically compare between all of the given things. Right. So next, again, assign, right click, assign new material. We are done with anisotropic. We can go for Fong. So Fong again has specular at as we have discussed, but it's a soft specular, right? It's basically something not as hard as we get in blend. If I talk about the blend wala thing, blend ka specular can go to the great extent. See, we have option to manage it, we have option to maintain it, right? When we come to Fong, we again get a specular setting. We have cosine power. That's the only extent it's gonna work about the specular. That's it. So it's the soft thing, not like blend. Blend gives us more flexibility, it gives us more options to work with. So high definition specularity wherever is required for the metals or something, we can use it. We can use the blend. When we talk about something small, something soft that ain't gonna require some specular, like very hard specular, we can use Fong. Easy to render, like takes less render time than blend, and at the same time it can produce certain amount of specularity. Okay. Another thing is assign new material. We have Fong E. you can easily differentiate between the quality of blend, Fong and Fongy. Right? I can put it here, something here. Yeah. So the quality of this specular gets low as we switch from blend to Fong to Fongy. Right? When we go, like when we land to Fongy, it has has a specular, but yeah, the quality of specular and the attributes that we'll be getting, the uh, what you can say is flexibility of playing around with the or tweaking with the attributes is quite low, right? So we have just very little access to the moderation into the attributes while working with form. The more we'll be having on is on your blend one, right? So these are the five that we get into your Maya software. If I talk about the PBR thing, the Arnold wala, or if I talk about the material of Arnold, the only thing that you have to keep in mind is that when you put this Arnold material, you have to use Arnold as the render engine. Render engine, this. You have to use the Arnold renderer to get the Arnold material rendered, right? You cannot render Arnold का material into Maya software का render engine. You can render Maya software के materials into Maya Arnold का render engine. Right? The lower version की things will work into the higher version, but the higher version वाली things not going to work with the lower version. As simple as that. Same works with Maya as well. While working on Maya, you have to get the file of the same version you have, or the lower version, the higher version file not gonna work into the lower version, right? Fine. So if I talk about the AI standard surface, I can write again same process, nothing new, assign new material, Arnold, delete this, and we have these all materials for Arnold. So we have AI standard surface. I can give the same color, but the tragedy is if I render, I can't see anything. Not a single thing. Although I have my this default light on still. Why so? Because as I'm telling you guys that we using PBR material, with PBR material we try to get realistic output, and this realistic output is only can be get by the interaction of material with the light. In this scene we have to get another light to support our mesh. Right? I'll go to lights and I'll get a shadow. Why not? If I render again, you can see things. This one is matte. Let me reduce the quality. That's intensity of the light. It's quite bright, so I'm just working with it. So we have discussed the matte material contain neither specularity nor reflection, nothing. So the matte material, that is our Lambert material, it has nothing, right? As we work with all four of these materials, including the AI standard surface, it all carries certain amount of specularity, it all carries certain amount of transparency, it all carries certain amount of reflection or refraction, basically your IOR, index of refraction. It all contains certain amount of those things. So when we get a light and we try to get it rendered into your PBR render engine, we can see the difference, easily see the difference between your matte material, your materials with specularity and refraction, and your AI standard surface material. Yeah. So what we can do is we can use either PBR render to get a output, or if we are working of AI standard surface, we have to get a this PBR render engine. But if you want to use these materials, we can easily get our render into this, and delete this, and I'll change my render engine to Maya software, that is the default render engine. And if I try to render right now, see, no property, nothing, just a plain color ball, right? But rest, it's just a color, nothing else can be seen. This is your AI standard surface. But rest are showing their respective properties and whatever attribute we have changed. Okay. So these are the different type of material that we have prior we have seen in the PPT, and now we have seen in your this software thing. So now let me tell you something more about their attributes, because each material possess some different attribute and some different quality of its own, right? So let's start with this Lambert one. We'll see each and every attribute, what exactly it does, what exactly it is used for. Most of the time in the 3D world, name itself suggests what the thing is made up of or what it is made for. Right? It says color. So if it says color, it's not going to add camera to the scene. It is going to add color to the shader or material, right? So right now it's color. You can change color, whatever suits you. Next is your transparency. So what transparency do is, as the name suggests, it make your mesh see-through. If I render it, see-through. You can see through the things. Your mesh. Right? Okay. So let's off the transparency to see other things. We have ambient color. See the difference. Till the time we ain't using ambient color, we are not getting any sort of lighting through the or the lightness. Ambient basically mean is the surrounding, so it includes the surrounding light to interact, but it's different from specular. It's not specular, it's just a color, not light bouncing back. That's your ambient color. You can see I can render this. I'll take a screenshot. I'll increase the ambient color and again render it. Okay. So the ambient light wala part that is dark right now, that is behind somewhere, can be illuminated by increasing the ambient color. Right? I'll take screenshot again. I'll reduce it and I'll this what I'm increasing is incandescence. Incandescence is also known as self illumination. I render it. See, this is the part where light is not able to interact. Like light cannot light this part. What you can call this area is shade, right? when we talk about this lighting thing, or when we talk about the sketching part, we have highlights, we have shadows, and we have shade. So this is the shade wala part. When we increase the ambient color, it increases the highlights and make the shadows, make the shades dead. Different between shade and shadow: shade always created upon your body or upon the body, and shadow always be created beside or back or away from the body, right? So about this incandescence and ambient color, sorry, ambient color and your normal color. Ambient color increases the highlight and make the shades dead. When we go to the incandescence, it try to emit the color out of the mesh. So it basically, if I increase both the things, and I'll take a screenshot and then I take a render. This, we have just simple color. Okay, this, we have increased our incandescence, sorry, ambient color. This we have increased incandescence, and right now we are working on both incandescence and ambient color. So what it do is, it basically get your highlights, and when we talk about this incandescence wala thing, it get to emit light or color inside of the mesh, right? It's basically the color that is emitting. It's self illumination, it's the material interacting with the light and self illuminating itself without the help of any external source of light. Okay, fine. So these are the things. Then we have bump map. What bump map do is, basically it's a long thing to study about again, because when we talk about texturing inside maps, inside any 3D software, we have to work with maps. So bump map create the illusion of roughness, but not making changes in the mesh. It just create an illusion. If I can use any map here, and let me render. Yeah, I need to get a map from outside. This is not gonna work. You can see just like very little changes, because we need to get a map. What exactly it does, it is basically creates, I just break this because we need to get a map from our proper or normal or bump map generated from the image. So what exactly it does, it create the illusion of uneven surface or a rough surface to you know, make the thing look like rough, like tree bark or something. So we have to get the map generated from another software and include in it. Then we have diffuse. Diffuse the amount of color, nothing else. Let me get this. Yeah. Diffuse is color, like hue itself. How much color is will be using and not, it's the hue. Translucency, again, transparency and translucency, there are two different things. So it's a translucency, depth and focus. So we are not going to use it anyway. This is a translucency focus, exactly which point the light will be interacting and creating a translucent effect, right? So we are not using Lambert for all these things anyway. Mostly what we use Lambert is for, we basically use it to get another image wrapped up around it, or there's a color, I can use any image over it. See, We can wrap any certain image over our mesh with the help of Lambert, which is not requiring any sort of your specularity or reflection or refraction, right? Make it transparent, we can render it. So it's a transparent checker ball. So what we are watching is basically this is a map that we have called upon a mesh. So when we started calling maps on the mesh, it is now, changing into the bitmap thing. A procedural one, we don't have to call anything or any map on the mesh. We only can adjust things with the help of these attributes given below. Okay. Next, we have Blinn. That was Lambert. This is Blinn. I'll change it to it. Yeah. Fine. So again, with the Blinn, also you can call any map. We have checkers, like these are the inbuilt things. We can have a map saved on your computer. If I go to file and try to get a map, see, it's not unwrapped, is that's why it's what it is showing like this. I can change, I can get another one. See, what I did right now, I have called a map from outside the software. Now it's bitmap process. What we are playing with the attributes, that was procedural, right? Now we have turned to bitmap thing, and what we did is we tried and we called a map upon the mesh. This map I have downloaded from internet. You can download from anywhere. You can get it clicked, like you can click an image of that thing and then use that picture as a texture. So I can tell you again how to apply a bitmap. What you can do is apply any material. Never apply bitmap on the default Lambert one. The Lambert one was applied default, right? So apply any material, Lambert, Blinn, standard surface, whatsoever you are using. Right now we are using Blinn. We already have a Blinn. Go to this color wala thing. Every material, every shader have this color. Here you can call your map. So go to the color. Here you can find a small checker box. Click on that checker box. Go to the file. And after clicking on the file, you get this drop down menu. You get this attribute menu where you get image name and a folder like thing created. Click on that folder. It will redirect you to somewhere where you have placed your images. You can just open that and it automatically applies. If you are not able to see the applied texture in the scene, the shortcut on keyboard is 6 number numeric 6. Press that 6 number wali key and you'll be able to see all the bitmap textures in your view. Fine. So there we have this bitmap applied. So now when you apply any bitmap, your color and this bar gets locked. Because now you'll be managing things. You're not managing things. Whatever material is applied, it will be applied and it will manage the things, right? But still you can use transparency, ambient color, incandescence, see, right? Diffuse, and if we are talking about this blend, so we have specular thing like eccentricity and all. So yeah, you can manage all those things without any problem, but only whichever attribute you'll be using to put a file on, it gets locked. Okay, like we have put a file in the color and now it is locked. You cannot use manually these things, but yeah, the file is applied. You can work with other than all those things. You can use specular roll off, even specular color. I can pick this blue color, so the same color ka specular we have. I'll render it. See, there's the specular and that's your image. Okay, so these are the some small attributes that is like quite required, and you need to know all about it to work for texturing while working on texture, right? So next we have anisotropic. Anisotropic have almost similar. See, this basic common material attribute, all the shaders are going to have it, right? There's no change in color, transparency, ambient color, incandescence, bump mapping, diffuse, translucency, translucency depth, and translucency focus, right? There's no difference gonna be in these. They're certainly going to have different this special attribute editors, like specular shading. Specular shading, all the materials that has specular and reflection, all the materials have specular shading, but the parameters under it are different. Like Blinn has eccentricity. When you go to the anisotropic, it doesn't have anything calling eccentricity. Like it rather has Fresnel index, it has roughness, it has angle, it has the spreads, but it doesn't have anything that is known as your eccentricity. Hmm? Fine. So it has angle, I've told you, it has spread x and y, it has roughness, that basically the roughness of your specular, because we are working under the specular shading tab, and your specular color. Okay. It is using anisotropic reflectivity that comes default. So your reflectivity wala tab is dead. As soon as you uncheck this, you can manage the reflectivity again, right? Manually. Then we have Fong. Common material attributes will be same. Specular shading, like it has eccentricity, it has Fresnel color, it has cosine power. Right? Specular color same, reflectivity and reflectivity color same. Fongy, now it has highlight size because this is the material that has least specular attributes or parameters. So it only has roughness and highlight size, nothing about the eccentricity, nothing about your this your Fresnel color, nothing about your cosine power, nothing. Just roughness and highlight ka size. Then it has whiteness and differently specular color. Both the things are different. This is specular color and this is whiteness. So both the things are different, not the same. Lastly, AI standard surface. So I have to switch to Arnold. Okay, about Arnold Renderer, whenever you download your software, it might possible you will not be able to see. It is there, but sometimes what happens here, you're not able to see the Arnold wala tab here. What you can do is go to Windows, Setting and Preferences, go to Plugin Manager, and there these are all the plugins that Maya has. Okay. Sometimes you just have to open it. This is your Arnold ka plugin m2a.mll. In my system, it is loaded and auto loaded. What happens sometime when you install your software and first try to use it, you might not get this thing. If I uncheck this now, setting preferences plugin. Again, I'm right now using, so it's asking to force close or something. Right. If force close, see. There is no Arnold ka tab that we were using. The color is gone. Everything is gone. Everything related to AI standard surface, everything related to Arnold is gone right now. Okay. So what you have to do is window, setting preferences, plugin manager, check in. Takes time. Depends on your configuration. Okay. Not a problem. Let's start Maya again. And, I'm really sorry for this. It happens because it is a software. You can never tell. So my Maya is open and let me share the screen.
Ma'am, I think screen sharing is off. You can reshare screen also.
I'm doing that only, sir.
Okay, okay.
Trying
Fine.
to share it. Is it visible?
Yes, yes, ma'am, it's visible.
Okay.
So that's why we having incremental shape options here also.
Yeah. Now, when we get this problem, now I'll be able to tell the solution. Right. The thing that server's telling is incremental save that we get is file wale option mein increment and save. If we switch it on, like right now we are just studying. So whatever we lost, not a big option, not a big problem, not a big deal actually. But while we are working on any of the thing, like while we are working on a like very big project, we have been working on it for like hours and hours, and if like this any 3D software crashes, everything is gone. That time you have nothing to like look forward for, right? So what you can do is just check this increment and save wala option, and it just keep saving things, right? Okay. So I'll be talking about your AI standard surface. So I'm not going to make all the 6 balls. Uh, just I'll create one sphere and will assign AI standard surface material and attribute. My Arnold is on. You now you can like you know where you have to get your Arnold from. Setting preferences, plugin manager. Default, right, like with all the softwares, all the versions of Maya after 2016 wala version, we get Arnold while this installation of the software. So default it will be on Arnold only. As you open your software na, you'll get this thing only, the Arnold. So let me assign the material. Assign new material. Arnold AI standard surface. And again, if you want to render your scene, this is your render. Render is nothing but the 2D output of your 3D scene. So if you want to render the scene, you have to put a light. So go to Arnold. I'm not teaching lighting right now. I'm just telling you something that will be required to check your textures. Right? So just go to Arnold, go to light, get a sky dome. Nothing have to be done here. Just get a sky dome and render. Okay. So you get really beautiful render. Another thing that I would like to tell you guys that is included into texturing is this black thing. We call it contact shadow. Okay. This shadow is created when a surface interact with another surface. You can get the best example around you if you can see a wall interacting with a floor. That edges, that corners, it has this contact shadow. Even if there is a almirah or something standing on the floor, you can see this black shadow underneath there, underneath that almirah as well. Okay? This is called contact shadow. We get another map for this shadow, that is ambient occlusion map. It is quite required to make the scene more realistic and more more perfect actually. Without this it looks very flat. This shadow is required, so we have to have another map. While we used to work on this Maya software or mental ray, the prior we has, but with the Arnold we get default this contact shadow thing. Yeah. Okay. So we have this material, we have standard surface and demo. This is the weight, where again you can call any file, this file, to, and I have to set project first, and I have to teach you how to set project first. So let's just call a checker, right? So this is checker and render. Yeah.
Ma'am, we having more 15 minute now. So
Sure, sir. I'll bind up. Okay. So this is your file that we have used in our AI standard surface. Now, if you talk about the PBR material, it has hell lot of options to work for, to work from basically. That is transmissions, quite a heavy thing to work with PBR. It is gonna need a specific, like achieve like good specification of your computers. You like try to get like 16 GB RAM or something for you, or SSD. In that, for that matter, you need to have some good processors, because it will take a certain amount of GPU and CPU to process the thing, right? So here we have specular, color, roughness, IOR, all these things again. Specular, if I reduce, you can use this as another great thing that standard surface has is metalness. If I increase it, render, works more of a chrome material, more of a metal material than anything else. Just with one attribute, you can switch your mesh, you can switch your normal, any, I can increase the specularity again. You can change any of your thing to a metal ball just with the help of one attribute, where inside your PBR render engine or inside your AI standard surface. It has reflectivity, it has metal, all the qualities, it has specularity. I can decrease the roughness. Okay. The grains you are finding here, it is another a long tedious process of rendering. So just don't mind about it. You have to work on render thing up, regarding this. Okay. So yeah, this is weight of the color or map that we'll be using. And you can see now it has proper reflection, it has specular, and again it has your all the properties of a metal. Okay. So this is the basic quality of AI standard surface. Now I'll take a new scene. I'll tell you another fine thing, that is to set up project. Whenever we work in any 3D software, we have to make a set project folder that contains all the necessary information of that thing. Right? So you can make a project window, and you can, these are the folders that it includes by default, and this is the destination where you can make this. I have a project, so I'll go to my set project. I'll go to my desktop, FTP program. I'll go to my project folder. This is my folder. If I open it, it has all those windows, all those folders that I was talking about, and I'll get it set. Okay. The set project folder works. Now you do need not to go to search for the things. If I open scene, I get my scene. See, if I try to get any image here, I can just go to the folder and get my image, whatever is required. Okay. So this is the perfect thing to have before starting working on any 3D thing. Make a set project folder. Okay, so I have been talking about many things right now. Lastly, I would like to show you something related to glass that includes ray tracing. So what I can do is I can zero the color. It all has the same material. Let me put another material. So assign new material, Arnold AI standard surface. I'll get the weight 0. I'll get the color 0.
Ma'am, I think your video has been get stopped. Could you unmute and mute once, because maybe when you rendered, so computation may had a mute your video, ma'am. It may possible. So just please on off your camera. It would be get work, ma'am. Okay, anyhow, you are audible, ma'am, so we can continue because here visual presentation is also with us. Okay, okay, thank you. Ma'am, are you able to hear us? Okay, okay.
Uh,
Now it's fine, ma'am.
yeah.
Yes.
Okay. So really sorry for the interruption. It's it's just the network thing, because it's raining very heavily here, and so that's why the network is not at all steady. Let me share my screen again. So is it visible?
Yes, ma'am, perfectly.
Okay, thank you so much. Fine. So where were we? We have applied surface, and we have reduced the color. We have reduced the weight. That all is required. Now we have this some more things to do to make it transparent. Diffuse roughness, metal, nothing, transmission, increase it. As you increase the transmission, you can see it started getting transparent, right? So we have a different panel, a different tab for transmission or for transparency. This will help you see. Okay. Another thing is I need to get this opaque thing removed because I want it to be perfectly transparent. Let's get a render, a quick one. See, it's a sort of mirror now. It has certain transparency, but still we have, some noise. So let's decrease that noise and go to material and roughness. So increase it for the sake of proper transparent output. I think you can now easily differentiate between the previous output and this one. That noise, that roughness that we have prior, now we have reduced it and it is completely a transparent mesh. I've told you PBR take lot of time to render. Okay, fine. So this is the thing that we have used to make a glass. Fine. Even I can play around with IOR a bit. It is index of refraction to get my things straight up. And let's take a render. You can see a proper transparent glass out here. What I can do is I can assign this very material to all the other mesh so that we can easily see what difference would it make if it is a plain 2D mesh, it's a 3D mesh, it's a simple glass or a complex model. So I'll select all and let me assign an existing material that is glass. So let's take a render. Now as we have applied the same material, it is calculating ray tracing not only for one mesh, it will be calculating ray tracing. Ray tracing basically what exactly as name suggests, it is the interaction of the ray of light with with your mesh and your material so that it decide if it has to bounce back, if it has to penetrate in or intersect, right? So this is now it's calculating the ray tracing of all the four things. Okay. So you can easily see the difference between all four things made up of same material. I haven't changed the material. I have used the same material. It's just the model gets complex and more complex and more complex, and the difference that it shows. This is our 2D plane. This one is a 3D box. It's a glass, and it's a complex model. What you can see is what amount of light is interacting with which part of the model or material, and it is again giving another different, what you can say, different output which each option, right? So this we can conclude that although material plays an important role, modeling again plays equal important role. The better is your model, the better is your texture is, right? So these are the models that I have used, and I have provided with the material that is glass. I hope you guys have understood the thing, the types of material. Like I'm concluding now. I have
Ma'am, one
used
query is there, like if IOR is greater than 1, then they are asking, ma'am. IOR is greater than 1, then?
if IOR is greater than 1. Okay. Is my screen visible, right? My screen is visible.
Yes, ma'am, your screen is
Yes,
visible.
ma'am.
Okay, great. Fine. If IOR is greater than 1, so put it. You can increase your IOR here. That won't be an issue. Basically, every material, if we talk about physics, not the 3D world, if we talk about science here, stop sharing. Okay, I'm really sorry for the interruption. I hope things are visible right now.
Yes, ma'am, it's a visible but little disturbing. Meanwhile, I think I'm going to put like, for example, if you're talking about the index of refraction, so IUR belongs to each and every surface having their own property. For example, if you're talking about the water, or for example, if you're talking about the diamond, so diamond having a highest refractive index, and if you're talking about one refractive index, by default, one belongs to air only. So each and every material having different kind of refractive index. So same, you have to go with the physics, and accordingly physics, whatever the value we having a putting, same value we will put it in the Maya, 100% the same result will come. But meanwhile, you have to maintain the proper lights also, because like ma'am has also earlier said, lighting and rendering is a, like you can say, the brother and sister kind of thing, right? So either one, both are both important for a same place. If the light will not properly over there, then the result will not much better can come, right? So I think now ma'am is active, so ma'am, you can go ahead. So are there any at physics?
Is there anything else? Like,
Yeah, ma'am, I think some question. I'm just stating. 1 minute, ma'am. I think
Yes, as
I'm
per
coming to
physics,
back.
it may become concave or convex in shape depending upon the background and light.
so,
Once again, I will repeat, ma'am. As per physics, it may become concave or convex in shape depending upon the background and light. Question, ma'am.
so is it a question or answer? Like,
It's a question they are asking.
actually, I'm not able to understand what exactly they want to know. Like, as per physics, it may become concave or convex in shape depending upon the background and light. So, is it?
I think, ma'am, the question can be either convex when the shape is a concave, or convex when you're working with the light. It would be depend on the background and the light, or either
Okay.
shape is a concave or convex. Light,
Okay.
whatever light we are putting or background we are putting, there is no any further difference in that
Like
regard.
that, basically, what we can do is, like, I'll tell you. while talking about lighting, this shape used, the concave or convex shape is the, if the shape is there which is reflecting light, then definitely it makes a difference. But if the shape is not reflecting any light, the light is not interacting with the shape, that it won't take any, it won't make any difference. Like background is of anything, it won't make a difference. But mostly we we use a concave background, like we use a sphere when we try to make a default lighting. But if we make a manual light setup, we know don't need to use anything that is a circular or that ways. We have different shape of light that you will be studying when you are studying about the lighting.
Okay, anyone having any further more query? Like meanwhile, related to the lighting and all, we have an also additionally one more session. So we can go ahead. And meanwhile, I think we are checking several people are not able to go ahead to feedback form, right? Give us 2 minutes time. Post session, we will check it out and then it would be working. Just after post
Yes,
session,
we will
the
post
forum
it
we will
in
check out.
WhatsApp group also.
Ben, okay, one more question from one participant, ma'am. How much hours need to master Maya to produce 2 minutes of video?
2 minute of video you guys are talking about Maya or animation work on frames. Okay. 1 second have 24 to 30 frames. Depending, it has 60 frames now, 300 frames, depend on the speed. So if you're talking about of 2 minute of video, it gonna take almost a year to make. You are not able to make it alone. You need to have a team, those who are masters of their own field. If you want to be the master of the Maya, you can't be master of the full software. You have to be the master of any specific module, either modeling, texturing, lighting, shading, animation, rigging, dynamics, right? So full learning, like you will be like learning complete Maya is like making a master of none and ace of all. That won't work. So yeah, and depending, if we're talking about the hour of practice, so we try to make our student 6 to 8 hour a day to dedicate to the Maya, so that they would get a better output in them.
Sir, you are unmuted, sir.
You're muted.
Abhishek, sir, you are muted.
Oh, sorry. One more question from the student participant, professor. Like, is there any additional resources where they can get learn about the Maya and whatever, ma'am, you had to teach now?
Definitely you can. See, you can learn things. Self learning is very great. You can use several YouTube links. You can use several online sessions to learn. But what happens is, when you learn from a teacher or faculty, you have someone to get your queries cleared from. Like, online session will provide you only the things that they teach, you see, you copy, and you're done. What if you get a query? What if you have a problem? What if you want to know why? Those sessions are going to answer your things. So ultimately, you can use online resource, but as a faculty, I think we all need a guru.
Yeah, I totally agree with the ma'am because end of the day, yeah, self-learning is a really very important part. But end of the day, there should be a guidance. Like very truly, I would like to say about the Eklavya also. He was a self-trained learner, but meanwhile, definitely, live the teacher was not over there. But with a statue of the Dronacharya, he had a dedicated here self and he tributing there all of the practice and things over there. And finally, he was a great like you can into the archery itself, yeah, somehow there is a bad story for Eklavya and somehow Arjuna. So it's not right platform to talk about that. Yeah, but end of the day, any mentor, any guide is really very, very important, specifically if you want to learn something. Without guide or coach you are doing, definitely you can do. Because if we are talking about our time, definitely we having really very less resources. But right now in India, also several teachers or the professors who are into this one field, so at least now you're having a mentor. So without mentor, when we will go, it will take 5 to 6 years. But if you're having a mentor at that time, you can go a little faster. 1 year somehow you can get cope up. And like ma'am has said about the 2 minute of video, exactly it would be the 2800 or 80 frame. 1440 lump sum frame will come into the Indian 25 frame per second. So as a student, for example, just completing the graduation or master into the field of animation, and if they are making 3D animation specifically, I'm not talking about the stop motion animation, I'm not talking about the 2D animation. Still 2D animation will also again take time. Somehow if we are making a stop motion animation, at that time we can make a click of photographs and then we can go a little faster. But again, for stop motion animation, first of all you need to create the models asset, that will again take a time. So somehow if we want to produce something, that will take little time, right? So for movies also, again, like last day when I was here, like several people are a little curious about how engineering it's related to the animation design and all. So even for a single shot, for some small 2 second of Transformers movie, around 185 people working in that particular department over there, and that shot where the girl has been transformed into the robot character, that short name was from the Transformer 3 or Transformer second itself, that has taken around 2.5 months of time to go ahead. And for rendering also, I will share one of the video at last day. Somehow if you're talking about the rendering, that's again a very tedious task. When we completed the job, somehow if your configuration is not good, even like today, ma'am, when uncheck the Arnold, so automatically all Arnold feature has been off. Again, she informed to get load the data. Suddenly entire like a PC processors is trying to upload the same machine, same scripts over there. So suddenly it's a flatter ladder. Maya has been get crashed over there. Even commonly, I do believe ma'am may also maybe using Core i5 with 8 GB or 16 GB minimum RAM. So it's a happening. So we should not be worried. So we having a backup, safe scene ads. We should be always carry forward. Then only it's a much better. So any more query, any more questions from the participant side?
Yes,
I think
sir.
we are already running out of the time.
Yes, sir. There is one more question from.
Yes, sir. Please, sir, you demonstrate.
Are there any online Maya training institutions?
Online Maya.
See,
We will keep
right
it
now,
note.
everyone is teaching online. If you enroll in any of the college or institution, we all are having online classes. That same thing was happening there only, na, sir? Even there in.
Ma'am, yeah, classes is going online right now,
Our
but
professors, no, ma'am. For students, it's going on online. So here, participants, all
But for
professors
working,
and teachers.
but for working, I know that. For working professionals, we do have online sessions, right? We do.
yeah, ma'am, but not related to Jane having also online for professional. For mass communication, I think, for related to the commerce, not related to the animation, because till now it's a practical based course, and somehow the university people we are working on that, because laboratory is also very much important. So in an online mode, we are trying to develop virtual laboratory. When this kind of things will done, definitely maybe upcoming time. But yeah, again, it will take not a 1 or 2 days, on average minimum 9 to 10 months or somehow 1 year. Then it could be come into the next session in an online mode also. But even like earlier last day also had a suggested at a free of cost, like commonly if we are getting something we are not much happy, so again you can go to the Swayam NPTEL several courses. Either you want to learn animation, management, finance, commerce, even there with other dance related one of the course also from the Maharaja Shajirao Baroda University, ma'am, also. So you can get over the website swam.gov.in. Lot of contents is available over there. So as a beginner, you can start from there, and definitely end of the day a mentor required, then you should be go to the university or colleges to get learn about the same. So I think any more query questions? So Mike handing over to Bhavana ma'am. So we can conclude the session of today, ma'am.
Yes, sir. I request Janathan sir to conclude the session. If any other announcement is there, you can announce, sir. Janathan sir.
Yes, ma'am. Thank you very much, Professor Gupta. You give enough quality time for our participants. It is a wonderful session. It helped us to understand the different dynamics in 3D assets and its creations also. At the same time, I would also thanks to the participants who continuously engaged themselves and continued throughout the session and interacted with the presenter, and I believe that you have taken the so much of information and knowledge from the session. At the same time, we can promise you that tomorrow we have a wonderful sessions like principles, animation principles, and poly painting, and health related sessions also there. this is all about today's day 2 FTP. Thank you all.
Thank you so much, ma'am. Thank you.
We already informed you that feedback form will be shared in the WhatsApp group also. We will check that technical issue and we will resolve it. We will.
Yes, I hope sir both feedbacks is working. Because we have created the feedback in Jain University ID. Because of that, it's not allowing others to answer.
Yes.
So we made I just recreated the settings, sir. I think it's working. Ma'am, thank you so much for your valuable time. Really, like many participants are looking forward you in future also. They want more sessions with you. Really, it's a nice session. Thanks a lot, ma'am.
Thank you so much for having me.
Thank you, ma'am.
Thanks, everyone. So now it's a time for a one break. And very soon we will try to upload the content also to YouTube. And I think the last day, the problem what happened in an online mode from YouTube only, we had a try to remove that dispute over there. So hope the same link up to evening, they will relieve to be play. So again, in a compiled mode, I will share everything. And meanwhile, what we are doing already, you may have registered yourself into the Google Classroom also. So we are properly making the structure in the Google Classroom. So whatever the content or resources that would be with related to our 5-day of entire course, ATAL FTP course, that would be also get available to you, but that will take little time because before finish up the sessions, all the data would be get available with you on that Google Drive sessions. Can I have feedback?
Yes, I am posting now. Yeah. This Google form is day 1. We will post both day 1 and day 2 in WhatsApp group also.
Yeah.
Tomorrow morning sessions will be begin at 9:30 exactly.
9:30.
Yeah. And tomorrow again, morning session as sir has and ma'am has said, 9:30 only we will get a start. And we do believe we are praying God, ma'am should be also healthy and internet should be get work. Because tomorrow we have a session from ma'am only. Because in online mode, it's really very challenging while we are somehow little stuck if our internet is not properly responding. So thanks a lot and namaskar from the Varanasi, Kasi itself. Have a good day. Take care, ma'am. Thank you.
Thank you,
ma'am. Thank you, ma'am.
Thank you all participants. Thank you so much. Have a nice day. We will wind up the session.
Thank you, ma'am.